gases at room temperature and pressure. Gases at room temperature and pressure. RTP. And then we also have to mention that from C1, it should be from C1 to C4. Now, from C5, we are from C5 to C17, they are liquids at room temperature and pressure. They are liquids at RTP. And then we also have to talk about what we call the boiling point and the melting point. Now, they have a low, their boiling point, low, boiling, and melting point. Low boiling and melting point. And also we should understand that the boiling point and the melting point is dependent on what you call branching. Now, what do you mean by that? When we talk about branching, we are saying boiling point, the boiling point, boiling and melting, boiling and melting point increases. It increases with branching. The branching of the alkanes. It increases with the branching of the alkanes. For example, we have pentane. With a boiling point of that is 36 degrees Celsius, which is normally a low boiling point. Also, when you talk about the physical properties, we are looking at the structure, or even also the physical structure, and even also we are looking at what you call in terms of the 3 states of matter. So that's why we even classify them in terms of gases and even liquids, and that is that. Now let's move on to the chemical properties. The chemical properties of alkanes, the reactions of alkanes, and also we look at what we call isomerism. We look at the isomerism, how they form isomers, and we go on to what you call the other thing. Yeah, I got this thing. Yeah, we have the chemical properties. Now, and the chemical properties that we have, the first one, like we said, also we should know that alkanes are saturated hydrocarbons. Alkanes are saturated, they are saturated they have what we call saturated single covalent bond. What does the word saturated mean? The word saturated it means that they do not do addition reactions. They do not do addition reactions. They are not involved in addition reactions. And also, we need to understand that the word saturation, what does that mean? It means that they have a single bond. They have a single bond. And the second thing about the chemical property of alkanes that we need to know is that alkanes carry out what you call combustion reaction. Now, in combustion reaction, we have two types of reaction there. We have what you call a complete combustion, and incomplete combustion. Now, in the complete combustion, the reaction is taking place in sufficient supply of oxygen. Sufficient supply of oxygen, and then incomplete combustion, it takes place in a limited supply of oxygen. Now, also we should also look at the products of those two reactions. The incomplete combustion, it will produce what you call a gas which is very poisonous, which is called carbon monoxide. Now, for carbon monoxide, you have carbon monoxide plus H2O. Now, this is a gas because it's steam, and this one is a poisonous gas. And how do we know that it's a poisonous gas? Because carbon monoxide is going to reduce the capacity of oxygen binding with hemoglobin. So it is going to remove oxygen. Instead of oxygen binding with hemoglobin, rather carbon monoxide is going to bind with hemoglobin. So how is it poisonous? It reduces the capacity of carbon monoxide, oxygen binding with hemoglobin. Now, in complete combustion, we have CO2, which is a normal gas, and then we have H2O, which is steam. So these are the chemical properties. Then we have our last reaction, which is the substitution reaction. Now, for the substitution reaction, we have one thing that we need to talk about, one condition. For the reaction to take place, it needs to take place under what you call UV light. Now, in substitution, what are we saying? Substitution is just you are removing another, maybe let's say you are removing another factor to put another factor. So, for example, we are saying, in terms of, let's come back to chemistry now. We are saying you are removing another element and substituting it with another element. For example, we are removing, let me not say removing, we are replacing another element, e.g., that will be hydrogen. We'll be removing, replacing a hydrogen there with a halogen. For example, the halogen can be either chlorine or fluorine. So these are the two types of reaction that we have. The reason why they can do these two types of reaction is because they are called the saturated hydrocarbons. And the last thing that you need to know is that alkanes can be used. Alkanes can be called olefins. They can be called olefins. What do we mean by that? What we are trying to explain is that they are used to make fuel. That's why they are called olefins. And that is the chemical properties of the alkanes. And what I want you to also understand is that these reactions are dependent on one property. The property is that they are saturated hydrocarbons having a single bond, and they cannot do addition reactions, and they can only do substitution reaction and combustion reactions. So there are only two types of reactions that we can talk about when it comes to alkanes. Now let's go to the different examples of alkanes. I'm going to do 4 examples of alkanes and even draw the molecular structures. So let's look at that. Let's look at that and see where we go. Okay, now the first alkane that we have is called methane. The word meth means one. It means one carbon. And then we have what we call eth. The word eth means two carbons. And then we have the third one. It is called prop, which means three carbons. So when you look at this thing, you can just come up with the conclusion that you are just using what you call the polygons when it comes, you learned about that in mathematics. Then we have the word butte, which means four carbons. Then we have pent, meaning five carbons. Then we have what do you call hex, meaning six carbons. Now we said that the first one that we have is going to be called methane. Methane. Then we said we have a general molecular formula of CnH2n plus 2. Now let's look at this. We said the word meth means one. So if you want the formula for methane, what are we going to do? We are just going to use this general molecular formula. So it's going to be Cn. The word N there stands for the number of carbons, which means is 1. Then we have H2 is H2n plus 2. So multiplied by 1 plus 2. So you put this one in bracket, you have C. So it's 2 times 1 plus 2. You're going to have 4. So your formula here is going to be CH4. Then you draw the structure. It's going to be C like that, having 4 bonds. And one point that I need to emphasize is that in organic chemistry, the carbon element should have 4 bonds around it. And there is one thing that makes carbon to be able to do that. When carbon is doing that, it is called what you call a tetrameric element. What do you mean by a tetrameric element? It is an element that always has 4 bonds around it at all times in organic chemistry. Also, you can look at this in terms of charges. Carbon has a charge of plus 4, so it will always have 4 bonds around it. So we will continue with the formula for ethane. We have ethane. Now, with ethane, we have CnH2n plus 2. So, we said where N means 2 carbons. Now, it's C2H2n times 2 plus 2. So, it's 2 times 2. Which is going to give us 4 plus 2 is going to be 6. So our formula is going to be C2H6. C2H6. So that is how we find formulas for all the alkanes that we have. Now, with that, we can write the structure of ethane. Now we have 2 carbons, and like we said, we should have 4 bonds around every carbon. Then we write the hydrogens on each side. So now that is the structure of ethane. So you can go on and on until you reach decaying. You can go on, you do dot decaying, you move on with them, then we will continue from there. Now let me touch the last part. The last part of our lesson today is what you call the test for saturation. Test for saturation. Test for saturation. Now, with the test for saturation, we'll be testing for saturation. Test for saturation. Now, in this one, will be having an alkane and an alkene. Now, for example, we are saying we use bromine water. We use bromine water. Now, for example, we are saying when you add bromine water in an alkane, what will happen? Like we said, alkanes do not do addition reactions. So in an alkane, the solution remains the same. Solution remains the same. When you add bromine water into an alkane, the solution remains the same. You can say it remains the same, or you can say no discoloration. No discoloration. You can even continue to say it remains the same or no discoloration. Now let's take for example, we have an alkane. Let's take CH4 plus Br2. What do we have? So we are going to have what? No reaction. So what happens? The bromine solution remains the same. There is no reaction because CH4 cannot do addition reaction, but can only do substitution reaction, whereby we'll be substituting one hydrogen atom with one bromine atom. So it won't do addition reaction, rather it will do substitution. So we'll talk about this kind of reaction in substitution reactions. Now let's take for example when you have an alkene. Now what happens? The solution changes from reddish brown. It changes from reddish brown to colorless. Now you should be asking yourself, why does the solution now change? The reason is that the alkenes, they have what you call what? They are called unsaturated hydrocarbons. So they have a double bond. Let's take for example, we have ethene. Let's say we have ethene reacting with bromine. Now what is going to happen? So it's plus Br and Br, what we get. So what is going to happen is that this bond, it is going to break this double bond, right? Now we are not substituting, we are breaking this double bond. Now we'll be having C and C, then we have the hydrogens on this side, then we have the bromine this side, we have the bromine this side. Now it is like this, it is going to be 1,2 dibromoethane. 1,2 dibromoethane. So you can just name that. We'll continue with naming when we are dealing with the isomers. So now these are very simple reactions. Like we said, solutions changes from reddish brown to colorless. Bromine water, it is reddish brown. So make sure that you know that there is, when you can just say there is discoloration. Now you can even see that from the equation that there is discoloration, because we see bromine as part of our product. That concludes our lesson. So make sure that you take these things seriously, and make sure that you practice them, and you should know that your imperfections are the ones that continually keeps you going. When you feel like you're not perfect, but what keeps you going, it is your imperfections. Our perfections, they never take us anywhere, but our imperfections, they keep us going. Thank you.